whenever you are starting a new subject, it's important to, understand the context, understand why it's important today, but then also understand kind of the terms and the terminology, because these things get thrown around so often, and if you aren't set on those terms and taxonomies, it's very easy to get lost in things which are really nothing more than just names, right? So let's not get lost in the names, and let's talk a little bit about the taxonomy. So there's basically three main branches in machine learning, right? So the first is supervised learning. The second is reinforcement learning. And then the third is unsupervised learning. And, in later future videos, we'll talk a little bit the specifics of how these different subcategories are, different from each other. But just to give you a high-level overview, supervised learning basically comes with labeled data. Okay, so you have some sort of training data, and then you also have training labels. So you actually can create a model based on that training data and those training labels, and then you can apply that model to new data. With unsupervised learning, we actually don't have any training labels. Okay, so we have data, but none of it is actually labeled. And so we're not looking to build a model between, inputs and output. What we're trying to do is discover some sort of structure, some sort of inherent structure which may exist in our data, which we can't see by eye. And so that's what unsupervised learning is about. So dimensionality reduction, for example, is about, finding kind of what features are most important in your data. So when we can reduce our dimension, which means to reduce the features in our data, we can find out, which handful of features are actually the most important, are the most telling, explain the most about the data. And another common type of unsupervised learning is clustering. So, do these natural clusters kind of form when you take a look at the data? And how do they form, this is all about discovering that type of structure in your data. And so supervised learning, labeled data; unsupervised learning, unlabeled data. Pretty simple so far. And then there's this third beast called reinforcement learning. And we won't talk about that much. A quick kind of summary of what reinforcement learning is. Well, it's basically about how we can train agents or machines to be able to do things on their own and make decisions for themselves while they're in some sort of environment. And how can we develop reward functions and kind of the math to make machines determine decisions themselves through what we call reinforcement. Okay, machine learning, we're talking about solving problems, right? And these three different subcategories are basically telling you, well, what problems are you trying to solve? Just like a mechanic can be categorized as a car mechanic or a bike mechanic, a machine learner can be categorized as a machine learner who deals with supervised problems or one who deals with unsupervised problems. And this is really nothing more than that type of categorization. Okay, so don't get confused in the words, and make sure that sinks in. Okay, so, having discussed kind of the overarching categories here of machine learning, we can talk a little bit about the many different algorithms that exist in our machine learning toolkit. Okay, so just like a mechanic has, wrenches and screwdrivers and drills, machine learners have available to them this broad set of algorithms which they can apply kind of based on the problem that they're dealing with. And I'm not going to go through all of these algorithms here, but I did want to include this diagram just to help you as you track through your ML journey, you can kind of see, where you are in reference to, this assortment of algorithms that exist. And I do like this diagram because I think that it just shows kind of the vastness of the collection that we have available to us as machine learners. So anyways, I'm going to wrap it up there. I hope that kind of explains the basic taxonomy of ML and kind of these broad strokes categories. Take a look at this on your own, but these are some of those algorithms which then are used to solve the problems in these broader categories. So, just to summarize, if you can think of these broad categories as the type of machine learner you are, then these algorithms are kind of the tools that each kind of respective machine learner utilizes to solve the problems that they're dealing with. All right, so we'll pause there, and I'll see you next time.